Okay, so hello everyone. My name is Zvonimir, and sorry about this. And in the next couple of minutes, I'll try to introduce this software verification toolchain that we've been working on for a while now, called SMAC. Another thing I want to add: so I'm here representing a large team of people that has contributed to SMAC in the past couple of years. Verification, sometimes it's a daunting word. So before I even start, know that SMAC is actually fairly lightweight and automatic and so on. So it's not scary as some of the other verification tools that you maybe encountered in the past. So here's my main slide. So this is the whole tool flow that SMAC follows and that is implemented within SMAC. So if you take a look at the upper left corner, we take, let's say, C program as input, and then we compile it using Clang, we get LLVM, we run a bunch of analysis and optimization passes on this LLVM, and then such processed IR ends up in the core of SMAC, which is this LLVM to BPL box. So what LLVM to BPL does, it translates LLVM into a simple programming language or intermediate verification language called Boogie. So Boogie is close to logic and satisfiability solving. So it's a nice bridge between your input language such as C and actual solvers in the background. So for LLVM people here, we like LLVM because it gives us a nice canonical representation that is, easy to walk through and so on, and easy to process, much easier than all the nestiness that source languages often have. And we also like all the LLVM passes that are available to us. So we use mem2reg, for example, to greatly improve efficiency of our verification and so on. We rely heavily on DSA as well, because that allows us, again, to scale to larger programs. So, DSA, I guess one thing I want to mention here, if you want to implement a more stable and better supported pointer analysis, please let us know. Or if you already have one, please let us know. Huh?
I'm looking for a postdoc to do that.
Great. DSA is great, but it's not really supported anymore. So it's getting a little bit tricky whenever the version of LLVM changes and so on. We have to do updates on our own. Another thing about this tool flow, it allows us to add new languages that you maybe want to verify quite easy. So I had 2 undergraduate students working on this, and as a part of their class project, one of them added basic support for C++, and the other one added support for Rust. So using SMAC now you can check simple kind of Rust programs, and that's an ongoing work. And it was actually relatively easy to do it because we leverage LLVM tool flow. So we don't even look at Rust sources, we just work at the LLVM level. And then a little bit about our backend. So Boogie is the simple language that we're trained into. And by doing that, we can leverage a bunch of verification engines that Boogie already has. And we don't have to write our own. This is a kind of a list of features that SMAC supports and implements. It's all open source. It's on GitHub. It's easy to install. You can start playing with it within a matter of minutes. It's fairly stable. You can translate very large programs. We ran it on, this number is even a little bit low, maybe 500,000 or 1 million lines of C code, and no stupid crashes or anything like that. It is very automatic in its default mode, so you can automatically check assertions and the memory safety of your code. You can plug it into existing build systems, which is really important if you want to run it on large projects. So you can generate BC files and run it on that. We support concurrency. We have preliminary support for floating points, all sorts of other goodies. And the whole code base is actually still relatively small. It's 6,000-7,000 lines of C++ code. So, I encourage you to take a look at it or come to talk to me. Thanks a lot.